Assalamu alaikum guys, welcome back. Okay, so now in this video we are going to start out a new chapter, that is group 2 chemistry. Okay, group 2 belongs is actually the second column of your periodic table. Groups actually refer to the vertical column of the periodic table. Okay, now the elements which are present in group 2 are pure metals. Okay, these are known as alkaline earth metals. Their oxidation state is fixed at +2. Okay, meaning they have an outer shell electrons equal to 2, and they can lose both the electrons to form divalent positively charged ions, and that's the only oxidation state, that is the fixed oxidation state in which they exist. And the most stable oxidation state, no other oxidation state exists in our A-level chemistry. Okay, then going down, okay, these are the members of group 2: beryllium, magnesium, calcium, strontium, barium. These are all the elements which are in group 2. Okay, as we go down the group, now in this video my main focus is going to be giving you an introduction, on giving an introduction on all the elements over here, and the general trends which are there here in this group 2. Okay, this is going to be quite a revision for most of you, because we've already done most of the group trends and period trends in the beginning of the chapters while we were doing atomic structure and stuff. But now over here, let's just quickly go over them, and then the major part of this video, that is the trend in the melting points, and the explanation for that will be discussed. Okay, so let's begin. Alright, so first of all, the trend of atomic radius. Okay, as we go down the group, what happens to the number of shells? The number of shells, they start increasing, right? The number of shells are increasing. If the number of shells are increasing, that means more and more electrons are coming around the nucleus, and so it automatically means that the atomic size or the atomic radius will increase as we go down the group. And that's exactly what's happening. Beryllium has the smallest radius, followed by magnesium, then calcium, then strontium, and barium has the largest radius. Okay, then oxidation number is +2. Reactivity, what happens to the reactivity as we go down the group, and why? Why is the reason? The reason should be explained as well, because that's a question which was tested on the past papers back in one of the recent past papers, basically, in which the examiner asked us to explain why does the reactivity increases as we go down the group. And this is a general rule for both group 1 and group 2. Okay, now it's pretty basic and pretty easy. Okay, it was a 3-mark question, by the way, a 3-mark question to explain why does the reactivity change as we go down the group, and how does it change, for instance. Okay, now first of all, as we go down the group, the very first thing to note is the radius. The radius is increasing. Okay, if the radius is increasing, then the second thing to note is what will happen to the outer shell electrons as we go down the group. Why are we looking at the outer shell electrons? The outer shell electrons are basically the electrons which are responsible for a chemical reaction, for the reactivity of that particular element, because it's the outer shell electrons that these elements will lose in order to take part in a chemical reaction, right? So it's the outer shell electrons. What's happening to the outer shell electrons? They are moving far apart from the nucleus. Okay, now that's the second point. If the outer shell electrons are moving far apart from the nucleus, then what's happening to the nuclear pull on those electrons? Because the nucleus is positively charged and the electron is negatively charged, and as it goes further apart from the positively charged nucleus, then the attraction between this nucleus and the negatively charged electron, the strength, the force of electrostatic force of attraction, it will weaken as we go down the group, right? Because of the increase in the distance, and also because of the shielding effect. Shielding effect, guys, remember the concept of shielding effect? I have explained this like tons of times in the previous videos as well. Shielding effect is basically the shielding or the repulsive force which is provided by the inner shell electrons on the outer electron. Think of this as a force that protects the outer shell electron from the electrostatic forces of attraction. Okay, basically the shielding effect actually prevents the nucleus from attracting the outer shell electron. It weakens the nuclear pull. Okay, and the greater the inner shell electrons, the stronger the shielding will be, and the weaker the nuclear attraction will be. Okay, nuclear attraction is inverse or inversely correlated with the shielding effect. Okay, so now as I was saying, that as we go down the group, why does the outer shell electron, it moves far apart from the nucleus as we go down the group, and the nuclear attraction on the outer shell electron, it becomes weakened, and if it weakens, then that means it will become easier to lose electron, right? The tendency to lose the outer shell electron, it will rise as we go down the group. And if the tendency to lose the outer shell electron will rise, therefore as we go down the group, the reactivity will rise, because what is reactivity? It is the ability for these metals to lose electrons, right? That is reactivity. Only then will they be able to react with other elements if they are capable of losing electrons readily, okay, or losing electrons. So that's the major reason why the reactivity increases, and this question was literally asked for 3 marks, okay? So the first answer in the marking scheme was for the atomic radius mentioned. Okay, the atomic radius as we go down the group increases. Then the second mark, this was an additional point by the way in that answer, but still, to be on the safe side, you must mention it. As we go down the group, the radius increases, the shielding effect increases, the outer shell electron becomes less tightly attracted to the nucleus, and so it becomes easier for the for these elements to lose the outer shell electrons, and therefore the reactivity increases. Okay, so I've added 5 points in here. Radius increase, shielding effect increase, the nuclear pull on the outer shell electron decreases, and it becomes easier for these elements to lose electron, and so reactivity will rise. Okay. Then after the reactivity, let's move on to okay, these are all metals. Okay, only metals, pure metals. All the properties of metals will apply: malleability, ductility, conductivity, etc. Sonorous and stuff. What happens to ionization energy? Ionization energy, we have discussed this in a lot more detail in the beginning videos. Remember, for a periodic table, if you look at the periodic table, what was the trend in ionization energy? As we go up the group and across the period and diagonally, the ionization energy has to rise. Okay, over here, if we, instead of going up, if we descend down, the ionization energy will decrease, of course. It will reduce, because going down the group, what's happening to the radius? It is increasing. What's happening to the shielding effect? It is also increasing. What's happening to the charge density? The charge density is falling, it is decreasing. So therefore the outer shell electron becomes less tightly attracted to the nucleus, and so it becomes easier to remove the outer shell electron. So lesser energy would be required to remove the outer shell electron. So therefore the ionization energy will fall or decrease. These 3 points that I have repeated, they somewhat look similar to the previous answer as well, right? Again, why does the ionization energy fall or decrease? The reasons are asked several times, like tons of times on the past papers, and these 3 points are actually the points that would fit anywhere in the answer to ionization energy. Okay, radius rising, nuclear attraction falling, the ability to lose electrons rising, so easier to remove electrons, so that will increase both the reactivity as well as the ionization energy will fall. Okay, because ionization energy is the energy needed to remove the outer shell electron, so less energy would be required to remove the outer shell electron. Then coming to the shielding effect, it is rising because more shells are adding. Then coming to the charge density, I have explained that already, and it is the charge per unit volume. So as we go down the group, the volume rises, so therefore the charge density decreases. Then electronegativity. Electronegativity, what was electronegativity? We've discussed this already in chemical bonding. Electronegativity is basically the relative ability of an element to attract the bonded pair of electrons towards itself. This was the complete definition which I gave you. What is electronegativity? The relative ability of the bonded atom, bonded is a key term, to attract the bonded pair of electrons towards itself is electronegativity. Okay? So do not miss out any key term in this definition. I'm not writing it down because I've already explained that in the covalent bonding chapter. You can look through those chapters videos, but electronegativity will decrease as we go down the group because the charge density is decreasing and electronegativity is proportional to charge density. Okay, and also the atomic radius is rising, so again electronegativity, due to which the charge density decreases and due to which the electronegativity decreases. Okay, atomic radius is actually the major determining factor for most of the trends. Okay, so if you know that atomic radius, you can answer any of these. Alright, so now after this, let's finally move on to melting points. Okay, what will happen to the melting points as we go down from beryllium to barium? Well, it is expected that since the electrons are rising, so the metallic bond strength will increase, and so the melting point will increase as well. This is what we are expecting, but that's not the case. Actually, melting point decreases going down the group. Barium has a lower melting point than calcium. Okay, and let's see why. Why is that happening? Again, atomic radius. Radius is a very, very important factor. Okay, atomic radius rises as we go down the group. If the radius rises, what happens to the bond length? Length of the bond. Length of the bond will obviously rise. Okay, metallic bond length will rise. Since these are metals, so metallic bonds, the length of the metallic bonds will rise. Okay, if the length of the metallic bonds will rise, then what happens to the electrostatic force of attraction between the bonded electrons and the positively charged ions? If the bond length increases, then the attraction between the positive ions and the sea of delocalized electrons, it will decrease. Okay, it will decrease because the electrons and nuclei will become far apart from one another due to the increase in that atomic radius. Okay, then if this will, they will move far apart from one another, then will it be easier to remove the electrons? Will it be easier to break the bond? Yes, it will be easier. And remember in the previous video on bond length and bond polarity, I told you that the longer the bond, the weaker it is. So that applies over here as well. That lesser energy would be required to overcome that the sea of delocalized electrons with longer bonds, and hence the melting point will decrease because the lower elements, they have a longer radius. Okay, yep, a similar concept applies on the bond energies of halogen acids as well. Let's assume we start out from HF. HF is one halogen acid, hydrofluoric acid. Then comes HCl. Cl has a longer chlorine atom, so bond length is greater. Then comes HBr. Then comes HI, which has the longest bond. So the longest bond is the weakest bond, and so lesser energy will be needed to break this bond. The least energy, and the most energy will be needed to break this bond. Okay, due to which, since lesser energy is needed to break the HI bond, therefore HI is actually the strongest of all these halogen acids we have over here. And this completes our discussion on group 2. Alhamdulillah. Yeah, in the next video we do have a few more trends. No, the chemical properties basically. The chemical properties are very important, and the chemical properties will be discussed in the next lecture. Thank you so much.